Welcome. Today we're going to talk about some of the basics of figuring the size of a blank before you bend it in a press brake. You may get a picture of a piece, and it may look like this on the print. Okay? And it may be, this is 1 inch long. This is 1.5, and this is, let's say, 4, just for a number, okay? 4, 5.5, 6.5. So I have a 6.5 inch long piece. But is that how long the flat blank's going to be? Well, we think it's going to be longer, it's going to be shorter. It's actually going to be shorter than this before I bend it. Let's say this part is 60 thousandths thick, okay? Well, when I measure from here to here, I'm also measuring that 60 thousandths, right? But when I flatten it out, that 60 thousandths is here. But I've had to measure it 1 time, 2 times for a bend, which made it longer on the part and yet shorter on the, we'll call that flat blank length. And this is total part length, okay? So, as you can see, I'm already using abbreviations. So the first thing we're going to do, just have a look at that. I'm going to erase it. We're going to go back and talk about what the abbreviations you're going to see in my formulas are. If you don't know those abbreviations, then it's just going to look like Greek. So let's break it down and interpret Greek into English or Latin or whatever. So I'll erase this. So first thing we're going to do is start with the abbreviations, which I will try to keep on the board throughout my lecture. All right. So the first thing we want to do is we're going to talk about material thickness. Material thickness. That's going to be MT, okay? So how thick's my material? If I lay a piece of metal down, MT, how thick is it? Commonly, and it may be 60 thousandths, you may get as much as 375 thousandths on a piece of material. It's going to take a big press to bend that. But that's material thickness, all right? Then we have radius of the punch, Now, I know we may not even talk about what the punch and die is yet. We don't want to put too much into one lecture here, okay? So we're just going to talk about this. What the radius of the punch is. That is RP. Some people say punch radius. I'm going to say radius of punch because in the formulas you see, it's going to be RP, not PR. So let's not get it confused, okay? Then we're going to have, this is where it gets a little technical now, outside set back, OSSB, okay? Sounds like some kind of government agency there or something. All right, then we have bend, stick with me, we will get through this. Bend allowance. BA. Bend deduction. BD. And finally, what we had before, flat blank length. All right? FBL. Equals, I'm going to go one more, if you can make it here, total part length, TPL. Okay, now, remember, this is before bending, so it's flat. Before bending, it's flat. Total part length is after bending. Oh, and I probably should put one more on there. I'll write it up here. bend angle. I usually put a B and a little angle sign after it, okay? I think that's all. If I find another one, I'll stick it up there. All right, so we're looking at all this. And then you have this sheet of paper, and you will all get this, which talks about the sequence you have to do this in. I don't know if you're familiar with geometry at all, but you have to do everything in a certain sequence. You can't times this by 2 before you divide it in half. You got to divide it in half, then times it by 2, or whatever. If you do it out of sequence, it all changes. So we're going to give you an example. We're going to start with that, and we're going to go through how you do this. So the first thing I'm going to say is my material equals 59 thousandths. That's how thick it is, okay? My radius of my punch is 60 thousandths, okay? My bend angle is 90 degrees. Now, one thing we didn't talk about here, which is okay, is the number of bends. How many times do I bend it? On this part we're going to talk about is 3. So if I was looking at a part, 1, 2, 3. 1, 2, 3. 3 bends. So now I know I got 3 bends, and they're all at 90 degrees. We're not going to get into 45s or 135s or any of that. Just point of reference though, when you're thinking of an angle in a part, think of it as flat, being bent up. So this is 45. I moved 45 degrees from flat to get to it. This is 90. This, 45 the other way, is 135 degrees. So we don't say, well, that looks like a 45 to me. It's from the flat, we walk it around to it. And that's how we get to 135 degrees. Just so we're clear on that. There's a lot of little idiosyncrasies we can get into in another video. All right, so let's figure this out now. This is where it gets crazy. So, first thing we have to do is I got to figure my OSSB, which is, stick with me, tangent 90 degrees, because that's my bend angle, 90 degrees, divided by 2, all right? So I'm going to put that in parentheses. Everything you do in parentheses, do first. So that's in parentheses, and then this is another parentheses, times by material thickness plus radius of the punch, okay? Now this is why we like to do 90 degrees, because half of 90 is 45 degrees. And the tangent of 45 degrees, oh, it's wonderful, is 1. So 1 times material thickness, 0.059 plus 0.060. So I get 100 and, come on, John, think about it, 100. Oh, back up. Sorry, I read my paper wrong. 090. That's, I'm like, why is that not coming out right? Okay, sorry. I got a radius of the punch of 90 thousandths. My eyes dropped down. Radius of punch 90 thousandths. So 059 plus 0.090, 149. Times 1, OSSB equals 0.149. All right? That's number 1 thing we do. So I had to do the 90 first. It's inside the parentheses to get 45. Tangent of that. Then times that by this. It gets kind of crazy, but that's what you have to do. All right, that's algebra, geometry. All right, so number 2 thing we have to do is we got to figure out the bend allowance. Now we got to figure out the bend allowance. And bend allowance is, this is why you want to have this sheet of paper, because these numbers are hard to remember. Bend allowance is 0.017453 times the radius of the punch plus 0.0078 times material thickness. You may be tempted to round these numbers off. Don't do it. It will burn you, because a little change here adds up to a big change once we get to the bottom. So don't round them off. They're going to be several numbers long. Don't round them off. So we know this is going to become 090, and this is going to become 059. All right? So this times 0.090 is 0.00157077. Yes, don't round them off. Plus 0.00462. And then we're going to times that by the bend angle. So times 90 degrees. A little degree sign on there for you. There. Times 90 degrees. Holy buckets. Keep up. So I add these together first. All right? Because I'm going to put parentheses around those too. So I have to add everything there first. Ooh, that's not a parenthesis. That is. All right. So this adds up to 0.00230097 times 90. I'm getting there. So my bend allowance is 0.1827873. That's why you don't round these off. You round those off, it changes that immensely. Okay, I know you're like, oh my goodness, this is so boring. Well, it's kind of like learning to ride a bike. If you don't figure it out, you're going to crash. So, you know, I'm trying to hold on to the back of the seat right now for you, okay? All right, so draw a line. Only 2 more steps, promise. 3. Now I need to find out the bend deduction. Bend deduction, all right? So that is 2 times OSSB minus the bend allowance times the number, I should put that like this, times the number of bends, okay? So, what's OSSB? 149. 2 times that is 298. Minus bend allowance. 1827873. 1827873. So we do that first. That is 0.1152127 times my bend, my number of bends, which is number of bends 3 times 3 equals bend deduction 0.3456381. So again, if you rounded this off and changed that number, or rounded, if this was something weird and you rounded that off, it's going to change that. Times by 3, it's going to change that. Don't round off. All right, last one, yay. So this one's easy. Flat blank length equals the total part length minus the bend deduction. So flat blank length, total part length minus bend deduction. So my total part length, we didn't talk about, but my total part length, so I'll put it over here, TPL, was 5.5, okay? That was my total part length, 5.5. So I take the flat, I take 5.5 minus 0.3456381, which is my total, which is my bend deduction, and I get for my flat blank length 5.1543619. Now you've been, the moment you've all been waiting for. We get to round off. Get rid of that, because you're not going to bend a sheet metal part to within a tenth of a thousandth. Okay? If you're within a hair, you're probably good, and that's 3 thou. A tight tolerance on a sheet metal part would probably be 5 thou. Now we're talking about taking 3/10 off. I don't think anybody's going to lose any sleep over that. And paint's going to be more than that anyway. So this is how you go about it. You've got to know your material. You got to know your radius of your punch, your bend angle, the number of bends, and you prefigure this because you've already taken your part, like you talked about, and said, you know, this is 3, this is 1.5, this is 1. So if you do all that, 3, 4.5, 5.5, then I get my total part length. And then you start figuring it out. How thick's the material? Now, if you're working with material that's not ground, not sanded, not prepped, don't trust this. It might be 0.62. And if you want, we could actually run through that. If I did 0.62, this flat blank length would probably change by as much as 8 or 10 thousandths, maybe even more. Because you think about it, if I'm measuring 59 here and 59 here, but now I change it to 62, I just made this grow 3 thou and this grow 3 thou. So I'm going to have at least a 6 thou difference in my flat blank length. If I got a 10 thou tolerance, I just use up a lot of that tolerance right there. So what happens if you shear one a little short? Okay, so mine's supposed to be 5.154. That's supposed to be my flat blank length. But when I get done, I'm 5.150. And I got 50 parts already sheared. Oh man, what am I going to do? Well, I got 10 thou on every dimension. I've got 10 thousandths on this one, 10 thousandths on this one, 10 thousandths on this one. Oh shoot, I'm only 4 thou under. I'll just bend that one at 2.998. There's 2 thou I just used up. I just bend this one at 1.499. There's a thou I used up. I just bend this one at 999. Well, look at that. I just used up 4 thousandths. And I'm well within tolerance. I'm still a champion. All right? So, again, I'll go through it real quick, and we're going to pause. So you're going to start with knowing the material thickness, knowing the radius of the punch. This stuff you have to know. What's the bend angle? We do 90 in this class just because I don't want to get into all the 75s and everything else. That's for you when you get out in industry. Number of bends, total part length. Number 1, what's the outside setback? Boom. Number 2, what's the bend allowance? And these are not variables. These stay the same. Some guy with a brain twice the size of mine figured this out. And he said, that's what we put there, and that's what we put there. So you take this constant times the radius of the punch. You take this constant times the material thickness times the bend, not bend allowance, bend angle. Right? Times the bend angle. I wrote that wrong. Yeah, stick with me. See, even I make mistakes. There you go, bend angle, times the bend angle. Get this number, plus this number, times that. We're still working our way out of the parentheses. Here we go. Bend allowance. That times 90, there it is. So step 1, step 2, step 3. Now we're going to use what we already figured out, the OSSB and the bend allowance. Working that, coming down, bend deduction. Now we take everything we've done, keep piling up the apples. We're down here, flat blank length is the total part length minus the bend deduction. Bang. Thanks. Now when you get to class, you're going to be given this sequence of formulas, and you're going to be given a practice worksheet. This used to be homework. This is now classwork. So if you struggle through some of this and you're doing these in class, you can work with each other, peer to peer, and if you get stuck, you can work with me. So this changes things around. You're not at home cussing at the paper because you can't remember what I said. You got me anytime, day or night. You don't have to call me and wake me up at 2 a.m. either. You can put me up and watch me on video again and get it in your brain. So we're going to do this one in class together, at least the first 4 or 5. Then I'll have you take the other ones home and work on them. You want to get this down because eventually I'm going to give you a 5-question quiz, and you are going to do it in class, and it's going to take a while. But make sure, as you can see on my paper here, show all your work. Show all your work. It gets a little involved here, I know. But if you don't end up with the right answer, and you come back and go, oh, right there, that should have been 7177. And you just happen to write it down wrong. Or 7077, I wrote 100150777. That changes everything. Yeah, I done it too. So I'm okay. It happens. It's called transposing a number, and people in the industry do it all the time. And don't worry if you can't find it, maybe your friend can. You know the old saying, you can't see the forest for the trees. I'm too close to the problem to be able to see what it is. So sometimes when you come to class, work on the worksheet together, you get it figured out. But after you're done, you'll get this, all right? So, sequence of order, practice sheet, and then I'll even give you this. This basically goes down through everything again, how to do each one of those formulas. It's on the sequence sheet too. But this takes you down through a whole nother example, and you get it all done. And then when we're done and we got a good grasp of this, we'll start building the parts. So, good enough. Thanks.